Okay, so we're talking balance equations, page 226 in the book here, right? It says, how do scientists in different countries, speaking different languages, communicate the results of their experiments to each other? How do they represent information about elements, compounds, and chemical equations? You've learned that chemical substances can be represented with names and formulas. You've also learned that chemical reactions can be represented by word equations. We looked at that yesterday. Can we describe chemical reaction in a symbolic form? Yes, you can. If you look in the box there, you'll see there's a French sentence, and then there's some chemical formula, CH4 plus 2O2. Then there's in English, methane burns in air by reacting with oxygen to produce water and carbon dioxide gases. The same chemical formula. And then it's written in what appears to be Chinese or Japanese. I really don't have any idea. Does anyone know? I have no idea. It's not Russian, I can tell you that for sure. But you'll notice that it's the same chemical formula. Okay? So we're going to use these because they're sort of a universal language type of things. Okay? So what is a skeleton equation? Skeleton equation is a representation of a chemical reaction in which the formulas of the reactants are connected to the formulas of the products by an arrow. Blah, 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 blah. Right? What is it? It shows a reaction, a chemical reaction, if you will. Shows a reaction with formulas. And I'm going to write in brackets, unbalanced, much like myself during my concussion days, unbalanced. You had a concussion last night.
Brown sugar in the fridge, I didn't even know that.
Doesn't it keep it fresh in there?
I don't think so.
No? Okay, so skeleton equation is unbalanced. It's where you're going to start with. Okay? What do you guys know about conservation of mass? I know we haven't done the lab yet. I needed some time to sort of get things together. What do you know about conservation of mass already, Cole? He's got a concussion, so he's sleeping. Oh. Oh, okay, good. What do you know about conservation of mass already, Cole? Nothing?
The number of atoms on both sides of the arrow.
You read my mind. Ashley. You want to make it into type? You like it when I do that, do you? Shows a reaction. People say you can't read my writing, but my computer can read my writing. Yes, conservation of mass says that mass is conserved. There can't be, at the end of the reaction, it has to be exactly the same number of atoms there was at the start. So what we're really saying in our terms is that the number of atoms on both sides of the arrow must be the same. You can't make more hydrogen out of nothing. It has to be there to begin with. That's why I've got the scale going over there to see if it's changing or not. Okay? Looks like there's the odd person. Let's just go right to the examples. I'm not even going to look at the book anymore because they make it too confusing. Okay? So here's the sample one that I'm doing for you, so that chance a little bit later you'll have a chance, pardon the expression, to do some on your own. So I'm going to show you now how to do it. Okay? So if I ask you to show me methane plus oxygen gives you carbon dioxide plus water. When you burn propane, that's not propane, that's natural gas. When you burn natural gas in your furnace at home, combining with oxygen in your basement, you get carbon dioxide and water. Where's the carbon dioxide go in your furnace? Out the chimney, hopefully, right? And the water vapor as well. Okay. This is the skeleton equation. Methane, you may or may not know, is CH4. Oxygen is one of those diatomic gases, like Mr. Hofbrinkel, right? Oxygen is O2. It is not O all by itself. Some of you will make that mistake. We're going to have to work on that, okay? O2, oxygen. Carbon dioxide, you should know, is CO2. Water, I got a mistake here, don't I? What mistake did I make? I forgot the O. Major scientific faux pas. H2O. Okay, that is the skeleton equation. Now, this point right here is extremely important. You cannot change any subscript numbers. Cole, you should watch up here, not the book, because I'm not really looking at the book anymore. You cannot change any subscript numbers. What are the subscript numbers here? 4 and the 2 and the 2 and the 2 here. How come you can't change those? Do you know, Nathan? Like, it's just how it is. H2O, water is H2O. It's not H3O, it's not H4O, it's H2O. You cannot change those. That's how they bond. That's that whole crossover thing, right? You cannot change those. The only thing you can do is change the numbers in front. You see these blanks in here? Those are the only things you can change. Okay, Mike? You cannot change the subscripts. Is that clear?
Yes.
I say that, and I know that people are going to try to change it. Am I right? You've seen it before, haven't you? Yeah. Okay, Erica? Can't change the subscripts, can only put numbers in front, right? Okay, there's the skeleton equation. Here's the balanced equation. If you want, you can just put the numbers in front of the one that you did, but please put those blank lines there, okay? Where did I put numbers? Only in front. I'm missing one too, aren't I?
Yes.
Is that right? It should be a 2, shouldn't it? Oh, 2 mistakes in one day. I'm missing the O. That's because I cut and pasted from the other one. Thanks, Nathan. Good catch. Well, I guess we all make mistakes. Okay, that's the balanced equation. Now, did I just sort of make that up? Like, how did I get that? Okay, there are special ways, right? Here's the steps. You want to write down these steps. You want me to go back? Here's the steps to balancing. Here are the steps to balancing. Steps to balancing. We're going to write the word equation, unless they give it to you already, right? If they've given it to you, obviously you don't need to write it, right? So in this case here, we're going to be balancing iron plus oxygen, giving you magnetic iron oxide, rusted iron. Okay, that's step 1. Okay, we're going to write the word equation. Next step is to convert it to formulas, which is called the skeleton equation, the one where you don't care if it's balanced or not. Okay? So Fe plus O2. Why is it O2? Diatomic, it's a diatomic gas, right? It's not just O, it's O2. So solid iron at O2, and it produces F3O4. Okay, I would have to give you that. I'm thinking you probably wouldn't be able to come up with that one on your own, right? Where are the reactants? On the left. Where are the products? On the right. Correct? Right? Okay, here comes the balancing part. Stand on one leg. That's what the next step is. You guys aren't very funny. Count the number of atoms on the left and the right. Don't trip there, Mr. Smigelson. So, that whole day we spent on counting atoms on the left and right is for this very purpose. Let's count them. I like to write them, the elements on top of one another. So what are we talking about here? We're talking about just Fe, iron, and O. Those are the only elements present, right? Okay, here's that whole counting thing that almost everybody, in fact, I think just about everybody, did just fine on. So how many Fe's do I have on the left? 1. The way I like to do it is I put the 1 on the left of the Fe, because it's on the left. How many Fe's do I have on the right? 3. How many O's do I have on the left? 2. And Graham, how many O's do I have on the right? 4. I'll pause there for a second. Is it balanced in its current form? Mike, is it balanced? Are there the same number of FEs on the left as there is on the right? No. One is a 1 and the other is a 3. This is a 2, this is a 4. It is unbalanced. Whoa. These numbers must do what? They must match. They must match. No, I didn't do it wrong. What's It's always fun to do squiggle marks and see what it's kind of like, autocorrect, right? They must match. It's not balanced. What can we do to balance it? We can only put numbers where? In front. Okay? So you balance by adding numbers in front of the formulas. Okay? Balance by putting numbers in front of the formulas. Seriously now, I'm serious. I don't want to take it away. Okay? I'm serious. Oh, okay. Maybe it ran out of time. Alright. I'm going to balance by adding numbers in front. Where should I start? Kids always say, I don't know where to start. Okay? I need 3 FEs. Let's start with the first one. So instead of a 1, let's make it 3. I can do that by putting a 3 in front. Now I have 3 on the left, 3 on the right. Am I balanced? Not balanced. Okay, what do I have to do? Hello, Mr. John.
I asked you to pick up some work.
Oh. Okay, what do we have to do to make it balanced? I got to balance the number of O's, right? I got to make that 2 into a 4. How do I make that into a 4? By putting a 2 where? On the left-hand side, right? Now we have to count. The next step is to check by counting again. Now, if you've done it right, your numbers should match. It's not a bad idea just to double check. I now have, how many on the left? 3 FEs on the left. Ashlyn, you need to watch. 3 FEs on the left, 3 on the right, so we're good. How many O's here, Chance? 4 is good, and I've got 4 over there. I am balanced. This is a balanced equation. It also tells you the proportion. You're going to need 3 atoms of Fe for every 2 molecules of oxygen. Okay, it tells you the proportions to mix them in, kind of thing, too. I'll pause it. The question is, how come that space is empty? I put a space there so that you would see that you can only put numbers in front. I didn't put anything in there. What's really there? There's really a 1 there. Do you need the 1 there? No. So you can just leave it blank. If you want to put the 1 there because you like doing that, that's fine. I don't care. Okay. Let's try the next one. Really? You're still? Okay. Don't write the steps again. Go ahead if you want, but you don't need to, right? I'm just showing you the steps again. We're going to do a second one. Well, you should write the example, the black part, right? You don't need to write the blue, right? Okay, so here's the one we're going to do. Graham, hang on. Oh, calculator. See, it just, you know what? It was like 15 years ago that kids used a calculator like this, and now they do this with their calculator. It's so weird how that's changed. That's how they used to do it, or just on the table. They never did it with thumbs. Never, ever did I used to see a kid with a calculator with his thumbs. Ever. I tend to do it now, too. Terrible. Okay. Okay. So we got magnesium metal, nitric acid, which I'm going to have to tell you what it is, hydrogen, and magnesium nitrate. I'm going to have to tell you what those are. Here's the skeleton equation. I'm only going to start with skeleton equation with you guys, okay? Because it's very hard. There might be a few that you could do, but most of them are going to be hard because you're not comfortable with these kind of things. We haven't done a whole lot of those. So for the most part, I'm going to give you skeleton equations. Okay? Some of you that are going on are going to have to be able to do this type of thing. So magnesium metal is Mg, nitric acid is HNO3, hydrogen is another one of those gases. I'll give you a list of those. Magnesium nitrate is MgNO3 Is this one going to be harder to balance? Chance. Is this one going to be harder to balance? Yeah, how come?
There's more out.
There's more, exactly, there's more elements. Very good. There's more to it. Okay. I want you to do this part on your own. Count the atoms on the left and the right. I'll give you about 3 minutes, and then I'll do it, and we'll check and see if you've done it right. Go ahead. Count the atoms left and right. Erica, how many mg's on the left? Just one. Good. How many mg's on the right? What does that 2 mean there? Does that 2 mean mg's, or did the 2 just go with the NO3s? Cole, watch. The 2 goes with the NO3s, right? So there's only 1 mg. So far, we're balanced. Ashton, how many H's on the left? Ashton, how many H's on the right? 2. Okay, now we're unbalanced. Like there was ever any doubt. How many N's on the left? Just 1? How many N's on the right here, Mike? 2 N's, correct. How many O's on the left? 3. How many O's on the right? 6. Okay, so clearly we are unbalanced. Now, quite often, it's where do you start is the hard problem, guys, late. Right? It's where do you start? What do you think, where should I start? Remember, you can only add numbers in front. Where should I start? Well, how about we start with our H's, right? I got 2 on the right. How do I make there be 2 over here on the left? Put a 2 right there. What's the problem with doing that, Graham? When I put that 2 right there, what does that change? It changes the N's and it changes the? Well, I wanted to change the H. It changes the N's and it changes the O's, right? So now I have how many N's? Oh, well that worked out good, didn't it? How many O's do I have now? Over here. I got 6. Oh. Am I done? Is it balanced? 1 and 1, 2 and 2, 2 and 2, 6 and 6. Done. Balanced. How did I know to start with hydrogen? I knew that if I started with the magnesium over here, if I put a number there, it's going to change this one, right? Did I want more of this stuff over here? I don't want more of the NO3s. I got too much as it is, right? So always try to make smaller ones bigger as opposed to you can't make bigger ones smaller, right? Always go from small to big. Okay. Now I'm going back to the book. I want you to try some. Okay? Page 229. I only do number 2. Only do number 2. Don't try any more. I know you're excited. You want to do all of them. Only try number 2 on page 229. Oh yeah, there's about 8 parts to it, by the way.
Yeah.
Still feeling good? Not good? Okay. Go come on. All you got to do is write it down. You got Na plus Cl2 gives you NaCl, right?
Yeah.
Well, put a space there, and a space there, right? Okay, so to make it balanced, first thing you do is you count. We have Na and we have Cl's. How many Nas do I have on the left? 1. How many on the right? 1. How many Cl's on the left? 2. How many on the right? Only 1. Okay? You can only make numbers bigger. You can't make them smaller. The 1s are fine. The Cl's, the Nas are good. The Cl's have to be bigger. I need more on the right. I need to make it into a 2. How do I make it into a 2? Put a 2 there. Right? Now my Cl's are good, are they not?
Is that the bed rating?
Yeah.
Okay. That's a CL.
Yeah. Now my Cl's are good, but what's the problem? Now my NAs are bad, right? I now have 2 over on the right. I got to make the one on the left bigger. How do I do that? I got to make it a 2. Put a 2. 2 NAs, 2 NAs. 2 Cl's, 2 Cl's. Done. Make sense?
Can you do another one?
Absolutely. There's the skeleton equation, Chance. Are you writing this down?
What's 60 times 12?
Give me a sec. Let me finish this. My concussed brain can only one track. Okay, I've got K's and I've got O's. Chance, how many K's on the left? 1. How many K's on the right? 2. How many O's on the left? 2. How many O's on the right? Only 1. Okay. So I gotta make more K's on the left, and I gotta make more O's on the right, don't I? Does it matter where I start? Sometimes it does, but in this particular one I know it doesn't. Let's make the first one, let's make more K's, right? So how do I make more K's? By put a 2 there, right? Layton, you gotta watch. You're the one that asked me to do this one. Layton, you're the one that asked me to do this one. I need more K's, right? Okay, now my K's are good, but I still need more O's on the right. The only way to make more O's on the right is to put a 2 there. I just created another problem. Now I got to double check my K's. Look at that. How many K's do I have? Now I got 4. That's no good. I got to make the one on the left more. I got to make it 4. How do I make it 4? It's kind of like a puzzle. It's kind of very much like a Sudoku puzzle, really. How many K's? 4. How many O's? 2. 4 K's? 2 O's, right? All nice and balanced. Nothing. Well, if you want to put something, put a 1. Okay, there's a few more left there. Try C, D, E, F, and G, and so on. I'll give you a few answers.